Hello and welcome to Saturday's edition of Cracking the Cryptic, and today we've got a chance to cut the Gordian Knot, no less, sort of a la Alexander the Great, because Joseph Nehme has sent this puzzle to us. And look, I should have actually highlighted this before we started, but if I highlight what's going on down this diagonal, you will see that there is indeed a knot. There we go, a knot that needs to be untangled somehow or snipped. And yeah, why are we doing this puzzle? Well, it's because last weekend on our Discord server, I requested puzzles that were maybe slightly easier than average, or the average that we've been doing over the last few weeks, but still contained some really beautiful logic. And Joseph immediately suggested this one as being as sort of fitting the bill. Well, I then asked Mark to test this for me, and Mark did it yesterday, and he says it is a spectacularly good puzzle, but he said there is no chance on God's earth that I will get this done in half an hour. He said it's a very tricky puzzle indeed. So, we shall. I think he's probably telling the truth, to be honest, and this is going to be some test, but it's beautiful to look at, and I'll read you the rules in just a moment. I don't have much other news, in fact, today. We are just a smidgen below 1/3 subscribers. So if you do watch the channel and you do enjoy it, well, even if you don't enjoy it, but really if you enjoy it, that's what it's there for. Please do consider subscribing. We really appreciate it. What else? Over on Patreon, of course, we've got our loads of extra content at the moment. The thing that is proving very popular is our Wonders of the World Sudoku hunt, which is a sequence of puzzles based around things like Christ the Redeemer and Machu Picchu, and there are I think there's 8 puzzles altogether, actually, 7 for each of the wonders and then a meta at the end, and many of you have been successful in solving that, and really congratulations, and we're delighted with the feedback, and yeah, have a go, you won't regret it. Now, what are the rules of Joseph's puzzle? I shall read them to you. We have got normal Sudoku rules apply. Both marked main diagonals must also contain all of the digits 1 to 9 once each. So these, you can see, mark these in blue for us. So we've got to make sure this diagonal has all of the digits 1 to 9 once, and the other diagonal as well, obviously. In cages, digits must sum to the small clue in the top left corner of the cage, and digits cannot repeat within a cage. So normal killer Sudoku rules, that means those 3 squares there have to add up to 12 and don't repeat a digit. And clues outside the grid give the sum of the digits along the indicated diagonal. Digits can repeat along these diagonals, providing normal Sudoku rules are still obeyed. So those cells, those 7 cells there, have to add up to 36, and we can repeat digits, but obviously what we couldn't do is, I didn't mean to do that. What we can't do is, for example, that will definitely break normal Sudoku rules, but we could do that would be fine. So do have a go. The way to play, as usual, is to click the link under the video. Now I'm going to get rid of all the colouring and have a go myself. Let's get cracking. Now, I mean, it's very tempting, I have to say, to sort of highlight these cells along these big diagonals, especially, I suppose, as I actually do know, of course, this is a secret we sometimes impart on Cracking the Cryptic, but I do know what that main diagonal adds up to, because it must contain all of the digits 1 to 9 once each, and if you add up the digits 1 to 9, and we know this, it works for boxes, it works for rows, it works for columns, and in this puzzle it works for the diagonal as well, you get 45. So yeah, I mean, let's just take a quick look and see whether we can see anything interesting if we highlight all of these diagonals. And hopefully this won't be a complete white elephant. So, am I seeing anything there? Well, there are... Yeah, okay, well, there are 2 things I'm seeing there. The first is that in highlighting these 5 diagonals, I have completely highlighted box 3, box 5 and box 7 of the puzzle. So using the rule of 45, I know that these orange squares will add up to 3 lots of 45, which is 135. And I know the diagonals will add up to, what will they add up to? They will add up to 102, 149. 149 plus 45 is 194. So the purple squares add up to 194. These boxes add up to 135. And that means these cells have to add up to the difference between 194 and 135, which is 59. Is it? Have I done my maths right? Yes, I have. 59. And that means that we are going down completely the wrong track because there are 12 of these orange cells, and 59 divided by 12 is near as 5. And that means, and 5 is of course the very average digit. So this is completely useless. Sorry. Okay, that's not what we should be doing. The other thing I noticed when I highlighted all of the diagonals is that all of the cages in the Gordian knot are completely enclosed. So presumably we can add those up as well. Actually, those as well. Although I don't like that as much, to be honest, because what we look like we're going to be left with is nothing. It doesn't look terribly interesting at first blush. Let us add up these the cage digits. Shall I highlight these in a different colour? Maybe I will. Let's add these up. So we've got 45, 58, 60, 86, 98, 111, 144. So I've got 194 was all of them, minus 144, 50. I should be able to remember that, 50. So the purple squares sum to 50. Now, well, what have we got? We've got 12 purple squares adding up to 50. Again, that's not. It doesn't seem like a very propitious average, does it? Although, hang on, this. Well, it's interesting. If you look at the purple squares here, 5 of the purple squares are on the 47 diagonal. And the same is true of the 36 diagonal here. Is that worth looking at? I'm almost going to say no, to be honest. What am I going to get from that? I'm going to be able to say, so I can add, I know what those add up to, and I know what these add up to. They add up to 83. So I can get 83 in these. Right, no, hang on, I was wrong. I think I'm wrong. I think this might be interesting because there is actually quite a big difference between the 50. So at the moment, the purples sum to 50. But these diagonals sum to 83, which is a difference, obviously, of 33. And that difference has to be made up of these cells minus those squares, I think. But I'm going to do this slowly. So what shall we do? Let's highlight those ones first. Let's make those blue. And highlight these ones in a different colour. We'll make those orange. So, what we're saying, now let's get this absolutely precise. We're saying that orange plus purple was equal to 50. But purple plus blue was equal to 83. So if I deduct the first equation from the second equation, purple will cancel, and I will end up with blue minus orange equals 33. Blue minus orange equals 33, and that must be a problem. Not a problem in a good way, because blue is... How on earth... Yeah, this is forced. This is beautiful. It's beautiful and barbarically hard. Savage, I would say, because... what's the maximum I can make the blue squares? And bear in mind, I've got to make them as big as possible, because the blue minus the orange is equal to 33. Now, even if I put 9 in all of those, which I can't, I'd only get to 36. The reason I can't put 9 in all of them is I can't put 9 in those two. They're in the same column. So the maximum these can be is 17. The maximum those can be is 18. So now I've got 35 in the blues, and I've still got to deduct the oranges out, and I've got to get 33 overall. So the oranges have to equal 1. And this is the break-in. That was tricky. But have we now basically done what Indiana Jones did with that sword fighter and shot it? And basically we're now going to finish the puzzle with aplomb. Yeah, look, the 13... These two squares have got to add up to 4. And there's a 1 here. So there's got to be a 1 here and a 3 here. Almost the same here, but the same thing exactly going on by sort of symmetrically down here. Look, those two squares have got to add up to 4. There's a 1 here, so that's a 1-3 pair. 1, we've not put 1 on this diagonal yet. It can't go in those 3, or these 3. Or here by Sudoku, or here by Sudoku. We get the 1 in the middle of the grid. There's got to be a 3 on one of those two squares, because we've not put a 3 on this diagonal yet. Now this is beautiful. If this was an 8, you'd need a 1-3 pair into those squares. This square cannot be a 1 or a 3 anymore. So this cannot be an 8. That's a 9. That's a 1. That's a 2. That's an 8 now. These two have got to add up to 5. So and this square, look, can't be 1, 2 or 3 because the 3 is on the diagonal. So that's 4. That's 1. And actually, we're doing... Yeah, now look, 1s. I can just place 1 in the grid over here. I've now done 8 of the 1s, so experience tells me I should be able to get the 9th. It must go here. So all the 1s are done. Some of the 9s are done. Can we keep going with 9s? 9s have to appear in one of those two squares. What does that actually say, that cage? 28. Right, these two squares have got to add up to 11, because we've got 28 here, plus 2 plus 4 is 34. We know the whole box adds up to 45, so those have got to add up to 11, and they can't be 2, 9, they can't be 3, 8, and they can't be 4, 7. This is a 5, 6 pair. We can probably do that in all of the positions. Look, we've got the same pattern going on because of the knot in each of boxes 3, 5 and 7. So let's do it up here. We've got 33 plus 4 is 37, which means those two squares have to add up to 8, which means they can't be 1, 7 or 3, 5. They are 2 and 6. Not 3 and 6, 2 and 6. Now, 6 I can see is not yet appearing on this diagonal. So 6 must be in one of those 3 squares in box 7. 2 is the same. We've got 2 here and 2 here. So 2 must be in one of those squares as well. And in this case, is that saying, is that 32 that's saying? Let me just double check, sorry. 32, yeah. So we've got 32 plus 4 is 36. These have got to add up to 9, and they can't be 1, 8, 2, 7 or 3, 4. So those are a 4, 5 pair. And we can, what can we do? Can we get the third digit on this diagonal? That would be very handy, wouldn't it? Not sure if we can. So basically, I've used a lot of these cages up actually. So I think it must either be diagonal Sudoku or little killer Sudoku that's going to get us out of this mess we find ourselves in. Not sure. Let's have a look at this. 47 on this diagonal. At the moment we've only got 18 on it. So we need 29 more in 5 cells. So it's a very slightly higher average. But we could still put double 8 into those squares, which would give us 16, 34. We need 13 in those 3 squares, which is very possible. Yeah, and what I mean is, I don't have to exactly make 13. It's just can I get to 13? Because I can obviously adjust these 2 squares downwards, and you can see that actually those 3 squares have a maximum value of 17. So there's quite a lot of flexibility on this diagonal. I don't think that's where we need to look. Let's try the 34 diagonal. We've got some low digits on that one. We've got 8 so far. We need 26 more. Oh, right, okay. This is where we should look. We need 26 in 3 cells. Well, if they were all 9s, that would only give us 27. So we know that these must be 2 9s and an 8, which 2 9s and an 8. I don't think I know. Do I know where they go? I mean, I know I don't know where they go. I mean, do you know where they go? I'm not sure I do know where they go. Or you know where they go. I don't think either of us knows where they go. Right, let's look at another one. Let's look at 32 here. We've got low digits on this one as well. I've got 10 at the moment, so I need 22 from 3 cells. So the similar logic to this one, there are 3 open cells that have to be a reasonably high number. I can't put too many 9s in here either, because I've got to put 2 9s. Oh, no, beautiful. This is absolutely gorgeous. Because there are 2 9s in these 3 squares, we should ask the question, where does the 9 go on the main diagonal here? And the answer is we don't know. We don't have a Scooby-Doo where it goes. But we know that wherever the 9s go, the third box will have to have the 9 on its diagonal. So now look again at the 32 diagonal, none of whose squares are on the main diagonal. None of these squares can be a 9, because if we try and put a 9 in any of those squares, we won't be able to put a 9 on this diagonal. That is really lovely. So that's going to put real pressure on this now, because that means we've got to get to 22 without using 9. So we could have 2 8s and a 6, or 1 8 and 2 7s. Okay. No, but you can't put 6. None of these can have 6 on, because look where the 6s are. The 6s just don't overlap with the orange cells. So these squares are actually 2 7s and an 8. And therefore this square is not a 9. And therefore that square is a 9. So going back to the other diagonal, the 34 diagonal, it's a bit like yesterday where we had to play ping pong and go backwards and forwards between that amazing cage in Eudicos's puzzle. Now those two squares, what were these adding up to? 26. Oh yeah, okay. So these two squares have to be different. And these squares are 2 7s and an 8. This is very hard to notate because although obviously I've notated that these, each cell individually, it is true to say, has to be a 7 or an 8, there is far more about these squares. Because actually as a triple they have to be 2 7s and an 8, and I have no way of recording that. I might colour them in actually. Is that going to be sensible? Or is that just going to confuse me? I don't know actually. I think I might try and remember it because I don't want to give up my highlighting of the Gordian knot yet. Right, anyway, so let's think on. What have we done now? We've got 2 7s and an 8 here. Let's look at the 36 diagonal. I've not looked at this one yet. I've got 17 on it so far. So I need 19 more in lots of cells. That's actually not very helpful at all, is it, this one? In fact, I can get 17, 19. Yeah, I almost don't need... I almost can just pick the maximum values from those 3 squares and then just rattle a 2 in here. Don't even need to use this square to get that high. So these squares are not restricted yet, but that might change. So literally, maybe I have to now go back to this diagonal again. Is that what I meant to do? Because this diagonal... I can't remember where I got to with this diagonal. Let's check this diagonal again. So I've got... I think I thought about putting double 8 here, didn't I? Now I can see I can't put double 8 there. Let's just look at that. You can't put double 8 into these squares because then I can't put 8 into any of the positions on the 32 diagonal. So this diagonal has now been restricted by the work we've done on the other diagonal. So yeah, actually, you can't put 7 in either of those yellow squares. Because if you put 7 in one of them, you're ruling 2 7s out from the 32 diagonal. And we know that there are 2 7s in this triple. This is quite extraordinary. So now you can't put 7 at all. So the maximum value of those 2 squares... You can't put double 8, you can put no 7, so you can put 1 8 and a 6. That's the best you can do. So that's 14. 14 and 18 is 32. Oh. And 32, 44. I think I can get this square. But I don't think I can do better than that. I've got a maximum of 14 here. So I'm at 32 with these 3 squares to go. Now, if we take the maximum value, we get 49. Now, that means I can't switch this to a 2 because otherwise I'll only get to as high as 45. So this square is a 6. This square is a 2. These 2... we don't actually know what they are, so I almost think I have to delete that. Now let's check whether this 6 and 2 have given us anything. They have given us diddly squat. I think it's the technical expression. Good grief. Okay, sorry. I'm not sure this has actually been... This box here needs a 4 and a 5 on the diagonal. Wow, okay. What am I meant to do now? I've done killer Sudoku. I've looked at the little killer clues and then looked at them again. Is it so maybe it's the diagonals then. What am I meant to see on the diagonals? 3 actually. 3 on this diagonal looks like it's restricted a little bit. This 3 takes that one and that one out. This 3 takes that one and that one out. So the 3 on this diagonal is in one of those 2 squares, which I have no good way of notating. I will put black squares to indicate. I'll put 3s in the corner. Yeah, that's 3 in the corner. That's 3 in the spotlight, losing its religion. Now, is there anything else? 9 is also a bit restricted on this diagonal. Now I'm looking at it. We've got 9, 9, ruling out those 2. I think that one, the black one, can still be a 9. 9 can't go here. It can go there, I think. That one. Bobbins, yeah, look, 9 can go in 3 positions. So we'll make that one black as well. So 9 is in one of those 3 squares. So we've got a little bit of a restriction in this diagonal on 2 digits. And I don't think we've got enough of any other digit for it to be restricted. I'm just going to check 3s, because 3, it looks like it might be possible to disambiguate these. If we get a 3 here, what's that going to do? That's going to put... I don't think that does anything. Three here. Let's look at 3 here. Does that do anything? I don't think it does. 9 here. 9 here puts a 9 here. That I can see. That puts a 9 there, I think. Because there's a 9 on the diagonal now, this would be the only place for a 9 in box 9. Aha, right, there is no 9 here. There is no 9 here. Let's look at why. If I put 9s into all the... If you put 9 here, you have to get 9s in these 2 squares. This one is the key one, because now I've got to put a 9 in box 7, and it won't go anywhere anymore. You can't put 9 here, here. These 2 can't be 9s, because I've already pencil marked them, and that one prevents that one from being a 9. So there is no 9 in this cell. Right, let's check this one. Can this be 9? If that's 9, you get a 9 there. You get a 9 here, because the diagonal prevents you from placing 9 here. You get a 9 there, and you get a 9 there. Ah, that works by the looks of it. Right, let's check that one then. So if this is 9, you get 9 here by Sudoku. 9 here by Sudoku. Oh, please break this box. Please break this box. You're not going to, are you? Are you going to break that box or not? You've got to put 9 on the diagonal here. It does break the box. Yes, it does. You can't put 9 on the diagonal because if you go 9s in these 3 positions, 9 has not yet appeared on this diagonal. It has to appear in one of those 3 squares. This 9 rules it out of this square. This 9 rules it out of that square, and this 9 rules it out of that square, so it can never appear on this diagonal. That is very difficult. So this square is not 9, and now there is only 1 square left for a 9 on that diagonal, and it's here. So I'm going to get rid of the colouring. So the black colouring will still relate to the losing its religion 3. We've got 9 now. Now 9, when I looked at it before, I think I can place all these 9s if I'm careful. 9 must go here by Sudoku. 9 must go here by Sudoku. It can't go there because it's on the diagonal. And therefore 9 must go... Do we get this one? Yes, there's a 9 on the diagonal taking care of that square. So this is 9. And this is 9. And I think... 1, 2, 3, 4, 5, 6, 7, 8, 9. All the 9s are done. We've got a 9 here, which had a partner 8. We had to put 9, 9 and 8 on the 34 diagonal. So this square is an 8. That gives us a 7 on that diagonal. Not sure. Those 2 squares look like they have to be a 4-5 pair now. These squares have got to be 3, 7 or 8. I think these squares have still got all sorts of options. I will actually put those options in though. 2, 6, 7 or 8. That can't be 8. No, sorry. Can't see what to do there. I've got a 7 on the 32 diagonal now. So these 2 squares are now a 7-8 pair. I'm definitely going to try and record that. I will not remember that. I don't like using red though. I will use maybe the grey. Yes, that looks better, at least to my eye. So what's that doing? Is that doing anything? I know what that's doing. I know what that's doing. It's looking at this square. This square is on the 47 diagonal. This is just, it's extraordinary. It really is. Is this going to limit this diagonal? So now, I bet it is, because this square can't be 7 or 8 anymore. That's now got a maximum value of maybe 6. I'm not sure if it can be 6. I can't see immediately why it can't be 6. This square is the interesting one to me, because it can't be 7 or 8 now, because if you put 7 or 8 here, it rules that digit out of both of those squares, and we know that there must be a 7 in one of these 2 squares, and there must be an 8 in one of those 2 squares. So this is not 7 or 8, and that, I think, has a maximum value of 6. So now this diagonal has a maximum value of 4 6s, 24, 18, 42, 47. We just have to populate this diagonal with maximums. So this is 6. This is 6. This is 6. Oh, sign of the devil making an appearance there with 3 6s in a row. That's a 5. That 5 means that's a 4. This is a 5 by Sudoku. And what else can we do with that? We must be able to do more with... This square is not 6 anymore. Okay, I'm not sure. I feel like I've put a lot of 6s in the grid there. There must be an opportunity to clean these up somehow. 6 is on this diagonal. It's not there. No, I can't see that. 6 is on this diagonal. 6 is... No, I think it's in one of those two cells. It doesn't seem to be possible to get all the 6s filled in, which is a little bit surprising, but... Okay, what do we do then? We've got to... the 36 diagonal has now got more digits than when I last looked. So now we've got 11, 13, 24, 28. These squares have got to add up to 8. Now I've remembered to try double 4 here. The other day I did a puzzle on the channel, and I think I had a similar situation where two cells like this had to add up to 12, and I forgot the double 6 option. It didn't matter for the solve at all. That double 6 option was removable fairly soon afterwards, but some people noted that I missed the logic, and you were quite right. So double 4 is possible. 1, 7 is not possible because you can't put 1 in either of those squares. 2, 6 is not possible because 6 can't go in either of those squares. 3, 5... I think 3, 5 is possible, bobbins. 3, 5 is possible. So this is 3, 4 or 5. Okay, so what have we got? What do we do now? We've got to look again. We have got I don't know what we've got really. This row I've got 5 digits in, so I need 2, 3, 4 and 5 into the open squares. This square sees 3 and 5 via the diagonal and Sudoku, so that's a 2 or a 4. This is 2, 3, 4 or 5. This is just 3 or 5. Not quite got any magic going on in that row. Bobbins, okay. Pencil mark this diagonal. I haven't really got much else to think about, I think, so let's check it. This square seems to have a multitude of options though. That can be 2, 3, 4, can't be 5 or 6, can be 7 or 8. This is not looking good, is it? 1, 2, 3, 4, this one's better. 1, 2, 3, 4, 5, 6. So this can only be 7 or 8. That is lovely. This square being 7 or 8 sees that square which can only be 7 or 8. So this square is a 2. Get rid of 2 from those squares. This column still needs 3 and 5 into the open positions. Ooh, these 3 5s, none of them see each other, do they? Don't think they do. That's very irritating. You naughty puzzle. Okay, sorry. Right, oh, let's just check this row while it catches my eye. 4, 6s and 7s into those positions. That can't be 6. There's a 6 up here. That can't be 7. 6, 7. No, okay. So what else have we got? We've got this square on the diagonal. This square can't be... It can be 2. I think it can be 4. This gets quite complicated to keep track of this. 5, 6 is impossible. 7, 8. 7, 8 can't be 9. This is beautiful again. Look, this square. This square and this square have to be different digits. So this is a 7, 8 pair. So this square cannot be 7 or 8 because then it will see both of those positions. It's just mesmerising that this logic keeps occurring in this puzzle. So this square's got to be a 2 or a 4. Which means that square in the corner is not 2 or 4. That's 3, 7 or 8. And now on the diagonal, we've got this square's got to be 3, 7, or 8 as well. And it can't be 7. So this is 3 or 8. One more digit to get rid of down here, and we're cooking with gas. 3, 8. I don't actually think there are many. We've only got 2 8s in the grid. We may only have 2 3s as well. Bother. 4, 2. We can. The 2 4 pair. Let's use the 2 4 pair. They see that square. Again, you can't put 4 in this square, because if you do, you can't now put 4 on this diagonal anymore. So this square has to be 5. That's 4. That's not 4 anymore. Another 3 or 5 here. This 5 sees that one though. That's got to be 3. So this is not 3 or 5. This is a 2 or a 4. There's all sorts going on now, isn't there? There is a lot of stuff I'm trying to keep track of in this grid. Okay. Got it. This 4 is ruling a 4 out of this square. Now remember, these two squares, one of the options was double 4. Once you remove 4 from one, you can remove 4 from the other. That's not done anything. Oh, you rotten thing. Has it really not? I think it has. It's limited 4 a little bit. 4 now has to be in this domino, I think, in box 8, which means 4 has to be in that domino in box thingy up here, box 2. You know what would make my day? What would make my day is this not being able to be 3 or 5. Because once I got 4 out of these two squares, these become a 3-5 pair. So again, this square, by this logic we've used over and over again in this puzzle, now can't be 3 or 5. So this square can be 2. It can't be 3, 4, 5. It can't be 6. I think it can be 7. It can't be 8 and it can't be 9. Oh, but that's still gorgeous. I mean, without this 3-5 pair, 3 and 5 would both have been possible in this square. So that's still pretty interesting. Now I can see that 8 is restricted in this box. It's got to be in the bottom row. In fact, it's got to be in that domino. So this square's not 8. 5. Where does 5 go in this box? 5's got to go here. It's the only place it can go. And that's going to give us this. Is this the point? This 3, 5 here. I just want to come back to this because it's so beautiful the way that came about. Yeah, I'm not quite sure I can see. Certainly this square not being able to be 3 and 5 forces the 5 down here, which in turn clarifies the ordering of the 3, 5. So it's definitely important for the solve. This square's a 5 by Sudoku now. That square's a 5 by Sudoku. This square is a 6 using pencil marks. That's a 7. That's an 8. That's a 6. That's a 6. Keep going. Come on. 8 here means this square's a 7. That's not 7 anymore. This, remember, we needed the greys were a 7-8 pair, so that's got to be 7. We get 3, 8 on the diagonal there. This 7 forces this to be a 4. That 4 gives us a 6 here and a 7 here. That gives us a 6 here. I don't want to get too excited, but it does appear that we are doing better, aren't we? Now that's a 3, that's an 8, that's just Sudoku. That transfers up the grid through there, look. Seem to have a lot of 3s in the grid. Indeed, that must be a 3 by Sudoku. That's a 4. This box needs 2, 7 and 8. We can place the 8. We can place the 7. We can place the 2. That's a 2 by Sudoku. This box needs a 3 and a 7, which we can do. The 3 fixes the 3 and the 8. This square's a 5. Don't mess this up. 3, 4 and 7 now. That's a 7 by Sudoku. That's a 4. That's a 3. This column needs a 7 in it. Hopefully it will go there. Now we need 2 and 8, which we can do. 2 and 8. Now in here we need 2 and 5. That we can do. Over here we need 4 and 8, which we can do, I think. And I think that's how to unravel the Gordian knot. Yes. Fantastic. Absolutely fantastic puzzle. And yes, I didn't get it done in half an hour. That was very, very tricky indeed. But what did I love about it? I absolutely loved the way that these diagonals kept sort of kicking the logic back and forward between them. And I thought that the way that where was it? I think we had 8 and 9 on this one. And we had 2 7s and an 8 on this one. And then we had the 7, 8 here, didn't we? Which operated down here somewhere. And we had the 3, 5 here that operated down on this square. And that happened over and over again. It was just gorgeous. It really was. Let me know in the comments how you got on. Let me know if you found other ways of solving it. I think I might get rid of the colouring. It's a bit of a hodgepodge. But yeah, it was an extremely brilliant puzzle, as always, by Joseph. And I can't get rid of the colour. Don't ask me to do anything technical. We'll be back later with another edition of Cracking the Cryptic.